not going anywhere. Classes will be here for the rest of your programming career. Yesterday, y'all heard me calling. One second. Yesterday you heard me calling the structs. Like I kept on wanting to say the word object when I was referring to these things. Structs aren't actually the object. The classes are objects. This is when we make instances of them. Some things that we need to know before, things we need to have before we start with classes, though, before the hype and the build up on it. I need to make sure everyone understands these three things. We need to have a decent knowledge of how functions are created and used. Who does not understand that? TJ?
Like decent, like.
If I told you to write me a function that adds two numbers, takes in two arguments, and returns the sum of them, could you do it and assign it to another variable?
Possibly.
Do it for me right now. 2 minutes. Okay, do it on the board.
Write it.
Yep, right on the board.
The function adds two numbers.
It adds the sum of two numbers passed in. And then I need you to invoke it and assign it to a new variable. The next thing we need to understand, scoping. What is scope? Or what do we use to define scope?
Squiggly braces?
The squiggly braces. Can anything be can variables defined inside of one scope be accessed inside of another?
No.
You understand that, Rulinsky?
Yeah. Two random numbers.
No, we need to take in two arguments. I shall invoke it with whatever numbers I want. Next thing, declaring variables. Everyone knows how to declare a variable at this point, right?
Yeah.
Okay. Why do we need a for loop? I just need to return the sum of two numbers that are passed in. Declaration. Or redefining a variable.
Just arguments throw me off when it comes to functions.
Well, they're not going to go away. Return x plus y, that's all you have to do.
Oh yeah, I got it.
Just don't, when you're thinking about it, this problem is so simple. You don't need to overcomplicate it always. There's writing on paper, watch your spacing. Everyone agree with this? Understand it?
Yeah.
Alright.
I just gotta stop thinking about it so much.
Yeah, so the only time we passing loops, like I'm gonna use a loop most times if we're using an array, but not all the time. We use it like a counter. You can use different things like that. This one I didn't need a count, so say I just needed to add them. Now how do I invoke this function TJ?
I can ride over here.
I didn't need you to put on the main stuff. I just need you to invoke it. You do realize system pause is not idiot, right? Like you're going way beyond what the problem's asking. It says you didn't invoke it.
Okay, so do I need to put LCD or?
Oh, I don't want you to print it out. I want you to invoke the function. The time I use the C out C in is when we want to display information to the user or ask input from the user. I think that would throw an error, but it may actually throw an error because they're named the same thing. I wouldn't name it the same name.
Okay, so. And we're just enrolling that.
I just need you to invoke that function and do something with the data. Preferably assign it to something, otherwise we're just invoking a function and invoke it and doing nothing with data. We don't need all. Okay, so watch. We don't need all this information, dude. No, I don't need all of this. This is all that would suffice. Int a is assigned the return value of add num that takes in a 1 and a 2. What is the value of a? 3. Make sense?
Yeah.
I'm gonna do a functions review real quick. Why do we use functions?
So you don't have to write out the same kind of code over and over again for different parts of it.
Yes, and we can use it in other parts of our code base and we have access to that function. What are some things to remember? They cannot be declared inside of each other. Correct? You cannot declare a function inside of another function. If a function has a return type other than void, you must use the return keyword and return a value associated with that data type. So if you have a floating, in the case of the int add function we just did, we must return a integer value. Correct?
Yes.
Any disagreements? If I was to return a floating point, can still return an int from it, but we don't really care about returning the int. I want to return more floats. So I'll just change all these to float, or you don't have to, but I will. And it will return the floating point value of left hand side plus right hand side. Same thing for characters and booleans. They must return an associated, like a data that represents that can be stored in that data type. Yes.
If a function is identified with one data type, but the definition in the space inside the function.
What kind of data type?
What?
Oh, I'm sorry. I didn't understand what you said, Redford. Like it kind of.
Sorry.
Yes. What you said?
If the function has the identification of one data type, like float on the top left,
yes.
But integers in the definition and the argument, wouldn't that cause conflicts?
No, it won't. So if you do this, so this is the definition. We know that, right? Yeah, we'll just call it the body for now. I don't know if I'm trying to spell the definition. This is the body, our definition. This is the argument list, our parameter list. Function name. Return type. The only thing it cares about is what's right here. Now, if you convert between the different data types, you could have like loss of data essentially. Because if you go from a floating point to an integer, you lose all those decimal places because the integer can't hold decimals, correct? It's not gonna cause conflicts. You just have like maybe have some unexpected behavior for depending on how accurate you need your math to be. Anything else before I move on? The function prototype, this is just a crash course on it. Function prototype, it is a function declaration that ends at a semicolon and has no body. So this is not here.
So this is a prototype whenever it doesn't have a body.
It doesn't have the body and just has a semicolon. It's a prototype. A function still needs a body. It needs to be defined somewhere else before you can use it. So the reason we do the prototypes is that we can put all our prototypes at the top of our code base and then define them later on. And it's also useful because we in the classes today, we're going to talk about using multiple different file types. When y'all create your source file, you see a header file in that selection window also. We're going to go over what that is hopefully today or next or tomorrow. Or something like that, depending on how fast we go. So that's why I'm stressing the prototyping on using them. We need to have an understanding of them. Does it make sense? Functions with arguments. What is an argument? An argument is some data passed to a function. As stated before, these arguments can be manipulated inside the function, used for condition checks, or even for other computation. So the arguments passed into a function can tell it to do different things, essentially. And we can get different behavior of a function, usually by chaining a bunch of if else or some switch statements, or just doing some kind of logic inside of our function. And we can have it return different data depending on what we want. Key thing to remember is arguments passed into a function are copies. Unless it's an array, then it's passed by, it's a reference to it, have direct access to the data in the array to manipulate. Something wrong? Oh. Any questions about that? Okay, I just want to keep to remember because Brent was trying to pass in for the example, the assignment this morning. He was trying to pass in an instance of the student class and then assign it from there. After the function's done executing, he would have lost that data because it doesn't stick outside the execution of the function, even though that argument was passed in, because it's just a copy of the data. When we get to actually memory management and stuff like that, we will have ways to work around this to where we can actually modify data passed into a function outside of an array. The argument list, it can be as very little or as large as you want. I've seen function arguments with up to past 16 arguments. I don't know what the limit is off the top of my head. I'd probably have to do some little bit of research, but for the most part, it's very rare that I've ever seen I've gone over 16. The only time I've gone over it was with matrix math and making those functions. And that was just for assignment stuff. See here, we have an example of a function that takes in 2 arguments. Same example TJ did on the board just a second ago. We added some numbers, takes in 2 arguments, left hand side, right hand side. And you can do this different ways. We can do this all in one line where we just return left hand side plus right hand side and be done with it, or we can assign it to a variable and return that variable. It all varies here, but it all depends on how complex your function needs to be. If your function is very complex, don't put it on one line. If it's not very complex, like this add function is, just put it however you feel comfortable. Whatever is easier for you to understand your code. Now I put limitations on y'all. Like I think it was Steven that I gave him an assignment where I told him he can only use 2 for loops and 2 conditions, right? And it made him think about the problem entirely different than what he was doing before. Will you be able to do that? Think of everything. I give you a limitation and try solving the problem a little bit differently. Move this out of the way. So yes. Does this clear up some of your concerns about arguments?
Yes, it does.
We'll go along 162, go to my main. This is calling the function with arguments. So on line 163, I just invoke the function add and give it 1 and 2. I'm not doing anything with the data it gives me though. So it's kind of useless to me right now, right? We should probably store it somewhere or display the information to the user. Where you can see on line 164, I just print out the return value of add with the arguments of 4 and 5. And I'm going to show you how to do it by passing in other variables into the function, which you can see on line 166. And we'll go over one more tidbit about functions, which is passing arrays into functions. As I stated earlier, passing an array into a function, you have access to modify the data directly inside of it, and it will stick after execution of the function. This is because the arrays have are pointing to those direct memory locations. We have access to the direct memory block to modify it. Unlike with standard variables in character, boolean, and char, all you have is a copy of it. So if you modify it, you're only modifying that copy. Good things to practice when passing in arrays around, especially anything that's not a character, because you can get the end of a character array pretty easily using string length. We pass in the length of the array also, so that way if we need to iterate over the collection, which most of the time we pass an array and we're probably going to need to iterate over it somehow, unless we have some kind of function that helps us out and does this for us to iterate over it, which we can do certain things like that later on. So in this example right here, I have add data to the array, which takes in 2 arguments, integer sum array, and then integer length. And then I just iterate over the sum array until we are 1 less than the length, because that's the condition. And I take the value of the array and assign it to I plus I minus 1, which it's something like, I think it was -1, 1, 3 or something like that. If I remember correctly, the return value of it, it's some weird pattern. I can't remember off the top of my head. But yes. And then I'll scroll down to my main on line 168, and you can see me invoking this function here. Again, I'm not doing. I don't need to assign the. It's a void return type. Perfect. Yeah, I think it's a void. Yeah, it's a void, so it doesn't return anything. So I can't assign the. If it did return something, I can't assign it to the function to another variable. I just invoke it and let it go. And the reason the data persists after execution is because why?
It's a modifier
Sorry?
You can't modify the data in an array.
I can modify the data in an array in a function, so it's stuck after execution because I had direct access to those memory blocks. When the array, you think of the array as the post office, where we have access to each index in the array is a post office box. You're gonna stay with somewhere in memory. This is post office box 0, 1, 2, 3, 4, 5. Because we know exactly where they are, because the array gives it to us, we can actually modify that block of data. So if I wanted to add, say all of these, this has like 4 letters, this has 2, 3, this one has 0, they just check the mail, this has 1, and this one has 0, they just check the mail also. When I pass it into the function says distribute mail, it gets all the indexes in the array and goes, okay, post office box 0, okay, you have 6 more letters, so you're at 10, you check your mail, your post office box getting 4, something like that. No mail for you today, here you have 1 new letter, you got another letter, you got 3 bills, so you have 4, and you have no mail for today. And after the function executed, it put all the mail in, we're done. And we can go back to wherever the array was declared at, and we can see all the data has been added to it and modified. Make sense? Just to re-elaborate on scoping, just make sure there's no confusions. Anything defined within the scope of a function is not accessible outside of that function. The only way we can get access to something inside of a function is if it's returned, and you get a copy of the data. That's the only way to get a value out of a function is to return it. And once you hit the return keyword, what happens?
All the other data is.
What was the big thing though?
Copy.
No. The return keyword, what does it do? It returns data and.
Then it's gone.
No.
Stores it.
Huh?
I would say stores it.
No. I'm looking for one word. Arta. It has 2 words, sorry.
Oh wait, does it cut off everything? Well, that would have been underneath it in the function.
It does. It stops execution of the function. It breaks out of the function as soon as you hit the return keyword. Everything after it's no longer executed. Good job. I understand this may be a little review for some of y'all, but I need to make sure everyone understands before we go on. Any questions? Renensky, TJ, Steven, Luke. Alright. So, again, y'all have access to these notes. And where are they at?
On your GitHub page.
On my GitHub page. You have access to them. I put them there for a reason. I know Brandon was looking at them for a while. So yeah. On to classes. So, here's let's go. Just so you don't have to keep getting up. Just put that right next to you. Anyone need to grab water before we start?
I do need a quick snack break. I'm getting hungry.
If you've been eating in like 2 minutes, yeah.
going back and forth on top of his mind as you were talking, and there's a small like spider web that I see like kind of.
As long as it doesn't land on me, I'm okay.
I don't know where it went though.
If you see it, let me know.
Yep, there it is right there.
I see it.
There's that little brown thing.
Get rid of it. Don't do spiders.
I mean, I don't mess with spiders, but I kind of like them. They get rid of all the flies.
I'll deal with the fly over spiders.
Thanks to the spiders.
I never saw a fly in here before.
They probably got them home.
Hey, that's how good it is.
That's how good.
Alright, he's coming back in.
I just need to quickly wash my hands.
Okay. Alright. So, on the classes. As I was saying before, classes are not going to go away. They're going to be here for the rest of your programming career unless you go into something that doesn't have class. Which, while you're here, it's not going to go away. C# is all classes. Python uses classes. C++ uses classes. It's not. It's going to be here.
You mean like classes or classes? Yeah, pronunciation.
So, what is a class though? The reason we started with structs yesterday is because the classes, they're very similar to structs in the way they allow us to create custom data types and how they're accessed. But classes allow us to, which structs do also, we just don't really mess with it, allows us to change how the data is accessed, essentially. We can restrict access to certain parts of a class using security level or protection levels. We're going to get more into that later on. But if you'll notice, yesterday with structs, we're able to access everything with no problem, right? All we need to do is the instance of the struct. With classes, we have to make things public. By default, a struct, everything's public. In a class, everything is private, which means it's not accessible. I see that spider web right there. Sorry.
Oh, so that's where that fireweb drifted off. I saw it earlier.
Yeah, no, it's no dude. So yes, classes by default are private. So we need to, if we want to access something, we have to make it public using a new keyword we're going to go over. And again, there's also a private keyword which makes things private. We can put them into structs also, We're not going to worry about that right now. Right now, we're going to leave the structs public. As you get more comfortable in your career or with your knowledge, you probably do some pretty interesting things with structs. As I said, classes are. So yeah, the overall design process is very similar as well, but with procedural, we're identifying data and operations. The structs, that's what's the procedural. With classes, we're using a thing called object-oriented design. All classes, they're objects, and we define how they relate to each other. Essentially, classes is both data, representing an object's internal state, and the operations, which are functions that can be formed on that data. With structs, we didn't put functions inside of them. We just use them as a data container, essentially. With classes, now we can give them some behaviors to go with it so our objects can behave differently. So again, we have a player object. He's not just a bunch of data like he was in the struct. Now we can throw some functions inside there and say, hey, player, you can move now. Okay, you maybe get smart and say he moves forward one space playing on a grid. Invoke that function, player moves one to the left or one to the right, depending on what we put in. This is a simple class right here. Utilizing the keywords private and public that I barely grazed over a minute ago. Class names, just like structs, they're unique. You cannot have two classes named the same thing. Classes are denoted by the keyword class, so on. Classes by default are private. You do not need that private keyword on top. I like to put it just because it helps me notify, yes, this is private data. Because sometimes I do forget that it is private by default, and that's just sometimes just moving too fast to go through things. Everything underneath private is not accessible outside of the class, which means if we made an instance of this sprite class, so I'll do it on the board real quick. Make an instance is just like a struct, so sprite, my sprite. If I wanted to access X, I could not because it's private, so I would try to do something like this. Dot X. Not accessible, we can't do it. But I do have access to those functions because they're public. But I invoke a function, it would be name of the instance we have, dot function name. I invoke the get texture function. And you see here, he has a couple functions that help us access that data up there because we don't have access to it outside of the class. So he made a couple functions that get the data, which will turn. So if we see get texture ID, it returns the variable texture ID, which is declared which is declared above in the private section of the class. And then he also has a set texture ID, which is of type void, and takes in a variable of type int, and then assigns it to the texture ID variable. You can think of the variables inside the class. They're also member variables. And they are kind of like the properties of a class almost. They are saying what makes up this object. Like what makes up a student? Age, name, DNA. What makes up DNA?
Chromosomes.
Different things like that. You can go on and on and on and on. Say a student's made of DNA, so we can have a thing called later on called inheritance, where things would inherit from each other, which we kind of grazed over in the last slide. You can go so deep with these classes and how you want to define them and make them part of another class using the inheritance stuff like that. But that's a later lesson. So, object-oriented design. It has 4 basic concepts: encapsulation and data abstraction, data protection and interface, inheritance, and polymorphism. We're only going to focus on the top 2 for this lesson, and I'm going to go into more about what they are in just a second. Object-oriented design is what we're going to live by. This is how we decide how our classes will interact with each other and how our code is going to be structured in a sense. And we'll go more on how to do it in a little bit. So, encapsulation, what does that mean? The class allows to encapsulate data and functions inside of it. So again, the class is just another big container for information, just like a struct, just with a couple extra things. Means we can group all the data and functions into one place. With this, instead of having to make a ton of variables, we can create the variables inside a class and make multiple instances on that class and gain access to the variable that way. We were already doing this with structs. We use structs so we don't have to make all those variables. As I said, we don't have to do this. Int player 1 HP. Int player 2 HP. So on and so forth. We don't want to do that, so we make classes and structs to handle that for us. We just make instances of it. So if we wanted to make make a player class, or we'll make a student class again, actually. So class student. What are some things that define a student?
Name.
Anything else?
Age.
Height.
And weight.
Weight. That's another big one that we did yesterday. ID. So we have a class so far, has no function in it, but that's not a big deal. We can add some functions to it later on. I'm gonna code at a certain point later on. I need to make a student. So I'm gonna make a student, and we'll make Luke. Now I want to change Luke's name. How would I do it? Can I do it?
No, because it's all private.
It's all private by default. So what do we need to do?
Make it public.
Make it public.
To make it public, you put the word of it inside the scope.
Yep, for the public keyword, which I'll scroll back real quick. If you look right here, put the inside of the scope of the function, we have the private and public keywords to say, hey, this information is public or private. It needs to be inside the scope though. Get it?
Yeah.
Once this is all public, we can make as many, like we have access to the data and stuff like that, so now we can change the name. Luke.mName is assigned Luke. We can name it like that, we have access to all that data. But with this, we can make as many students as we want. I can see this morning with the morning assignment with the struct, we made an array of 7 students where y'all made all yourselves into an application. That's what it does. Otherwise, we have to make all those variables. Which means for 7 of y'all, I would have to make 35 variables. No one wants to type out 35 variables. Especially if it's all repetitious. It's not just wasting time, I find. Make sense? So, as I said before with the example, it's not just variables that be stored in classes. We can also store functions as well. In storing functions, this is where the scoping and prototypes come in handy. We're not going to worry about it right now. We're going to go into the actual header and source files probably this afternoon. And as I mentioned earlier, that's how we're going to separate our stuff. So he has a function called void move right here, and we'll do the same thing. We have void change seat. And now we're not going to define it inside of the class. We will only do the prototype. This is why I was stressing using the prototype before. Because we will then need to define it, which we will do in a little bit. We will define it underneath our class or in a separate file. And then we can actually invoke this function, assuming it had a definition for it, which we'll pretend it does. How do we do that? We take our instance of the class that we want to invoke it on. So I'll do loop dot change seat. Actually, we're gonna make change seat taking a function. Sorry, an argument, not a function. Int seat num. And we'll do loop dot change seat. And we'll send you to seat 2. And that's how I invoke it. When we invoke a function from a class, we're invoking that function on that class or on that instance of the class. So it has access to modify the data inside of the class itself. Any questions?
So we're modifying the actual data, it's not a copy or anything?
So when a function has access to when a function is inside of the class, this function right here is change seat has access to all of this. Now, if arguments passed in, that argument is still a copy of the data. This is the actual data, though, because it's inside of itself. Alright, I'll repeat it again. When you invoke a function on an instance of a class object, you have access to all the data inside of that class. So this change seat function has access to this MID, MWeight, MHeight, MAge, MName. So it can modify it directly and the data will stick even after execution. Now if an argument is passed in, so like int seat num, and I modified seat num in the function body, that data will be lost after execution and it will be back to whatever was passed in, if it was a variable. You still look confused.
A little bit. So basically, this type of right here, it would automatically take the ones all the way up to the top. I mean, like run each code above it.
No, it doesn't run it. It has access to it.
Yeah, access.
Which means same thing with like the scoping. This is all called the class scope. Everything inside here. So everything has access to everything else inside of the class. So you can have access to modify it and change it and just print it to the screen or something like that, or just get it to do some other computation or logic with it.
Oh, gotcha.
Yes. This is why I was saying we need to understand scope, and I was trying not to use class scope just yet, but if it helps you understand it, we'll do that. Data abstraction. We're not going to go into this just yet in like really into detail. But one thing we thrive for as programmers is to be able to reuse our code over and over and over again. And we do this by writing or implementing generic classes. The goal with a generic class is to use it across multiple projects. And just keep on doing it. It means we can pass, like, say we wanted to do a math library, which I will have to do, but you want to handle both floats and ints, or maybe some kind of other weird data type that you define later on. You can make it generic to where it supports all of those data types if you write it correctly. Again, this is a more complex subject matter. We will be going into it later on. The next our next topic of object-oriented design is data protection. I mentioned it later on. We kind of went over it on the board. There's different protection levels inside of a class. There's public, which means all variables and functions below this area. So I'm gonna go ahead and just rewrite this real quick in a way where I can actually show an example of. Or is there an example already? So I can rewrite. It's okay. Here's an example right here we can use. We have this enemy class where it has its variables declared at the very bottom, which are private. Why would we need to use the private keyword in this case? Because we made everything else public and we don't want no one to have access to that variable, which is why we would do it. If we put everything on top, do you still need to use the private keyword? Everything else is going to be private, but in a class, everything is private by default. So we don't need it. I like to put it just because it makes clearly identifies this variable is private. One thing we have tried doing in the past is which these slides are following right here, but it was not following our previous slide, is putting variables at the bottom of your script or your class. I say I'm bad for it. I don't do it all the time. So I would say kind of we'll play it by ear. I'll consult with Mr. Matthew and see what he wants for that. If he says he wants to put them at the bottom or wants to put them at the top. I know that was a standard we tried implementing last year. With my class we tried doing when we worked on a project together. So I will consult with that and I'll get back on to y'all. So yes, we put the public to identify everything below it until we hit the next security protection level. Keyword is that security level. So yes, with classes we constrict is able to access variables and functions owned by this class. One use for this is to validate data passed to the object before it is assigned to a variable. So as you saw in the example where the get ID function I had on the board or something like that, you would call that function instead of directly accessing the variable, because you can maybe set some conditions. Say you need to change a player's health or a character's health. Should a player or character's health ever go below 0? No. Then you're really dead. So essentially what you would do is before the assignment is you would maybe use a function that says set player health, and that would do a condition. Is the new player, is that value, the value trying to be assigned player health, less than 0? No. Okay, assign it. Is it less than 0? Okay, player health is equals 0. Something like that. That way it doesn't go negative. Why would you want to do something like that? UI. Your UI may not handle negative numbers very well. So that's one reason you might want to do that. We'll go into more UI when we get to Unity and stuff like that.
In Fire Emblem games, it's impossible to get health below 0. That's probably intentional.
What kind of games?
Fire Emblem.
Okay. It's actually true for like most games. I can see it most useful for like games where the health bar is displayed to you, or show like percentages of it, and things like Mario 64, how you have the 3 triangles, things like that. You can run around with it. So yes. Again, this is done using the keywords public, protected, and private. I'm gonna go more into this in a second. In order for data protection to be done correctly, the class needs to be very well planned out. And we do this using UML diagrams, which we're going to go into in just a second. So just to continue to elaborate on the access specifiers, public, any function our class can have access to this member, which means that variable or function is accessible outside of the scope of the class. This does not mean, though, you can do this. just because it is public does not mean you have access to it without an instance of the class. So if I wanted to, this is the end of my scope. If I did M level, it's not defined. In order to have access to it, I need an instance of the player class. So just doing this, assign 1, undefined. If I made an actual instance of the player class, so I make a new player, and his name is TJ, and then I did TJ dot M level is assigned the value of 1, this would work because we have an instance of the class to get it through. Make sense? Now, when accessing it inside of the class, it's accessed a little bit differently, the member variables, and I'm going to go into that in just a little bit. We use another keyword. Protected. This is used when we do inheritance, which we'll go into a later lesson. Only functions from this class or derived classes or friends can access this member. Derived classes and friends will be covered later on. Which means, so this is kind of it's kind of like a between private and public. It's just the data can be shared between other classes that are or how do I say acquainted with each other. Yeah, that'd be a good word to say it. Or again, inheritance. They inherit from each other. I'm sorry.
That's it. Instead of using the word acquaintance, mutuals.
Mutual, yeah, that's another good one. They share the information with each other. They're really close. In some cases, they're actually the same thing with inheritance, where you can inherit a class from another one to become kind of the same data type. Private only functions from this class, and friends can access this member. This is the most secure your class can get. Nothing has access to it but itself, and of course the friends, which will go into friends later on. Friends is kind of a so. Kind of went over all these. One use for private is they're used to hide data and functions from which cannot be accessed by other objects. And then what we do, so sometimes these data that we want to hide, like variables, we don't want everyone to come on willy-nilly in our code to modify it. We give our code base to someone. We use functions to allow them to set those values. And it's kind of restated right here. Often public access or functions are used to access private variables to allow us to validate the data stored in them. Again, the player health example. And then we kind of have a couple examples right here, which y'all can look at later on. So, the next thing we're going to cover is, as I stated before, we need to very well be able to define our classes so that we can make use of the protection levels to their, like how they're supposed to. And we use this thing called the UML diagram. The UML diagram is a diagram we use to plan out the structure of a class or the structure of classes. They ensure we stick to a design and don't stray away from it. It does not always happen though. So as y'all saw yesterday, I was kind of doing a very meh UML diagram with structs where I just put the name and the variables. But now we have to introduce a couple new things. We have the security levels or protection levels with the classes. So we use a couple different signs to do this. So the way a UML diagram is structured is, I'm just going to kind of draw a very crude box up here, where the box on top, or the very top of the UML, is usually the class name. So we're going to make a player class. Or actually looks very neat compared to most of the time when I'm on the board. So we have this player class. Now we can define, we can start saying what defines this player class to be what it is. And we usually want to start off with our private variables. Our private data. Not necessarily say variables, because we can have private functions. We'll just refer to everything as data from right now. So, what are some things we want to be private? What are some things that define a player?
Health.
Health, so M health. And this will be an integer. So as you can see here, I have some very weird syntax look in our grammar on the board, where we use the minus sign. Let me write this a little bit bigger for you. The minus sign signifies this is private. So I'll write that over here. The plus sign, or the cross, says this is public. And there's one for protected. We're not going to go with that for now. When we're putting stuff in the UML diagram, we need to specify the data type and the name. So we say it's security level or protection level, name, semicolon, data type for variables. Is how we put into the UML diagram. Bear in mind, I'm going to do this very simple with UML diagrams. We do go into this more when we get into actually code design and data structures. I just need to have this because it's the easiest way I know how to explain the structure of a class. So there will be a couple missing information here and there, which will be elaborated in the later assessment. So we can do this. Now, that's private, means I can't access it outside of my class. So let's make a member or a function that's associated with class to assign that data. That function, so I can access outside class, needs to be what?
Public.
Public. How do we denote a public data in a class with the UML? The plus sign. We'll make a plus sign and make it public to make it public, and we'll make a function called set health. Functions are a little bit different in a UML diagram than variables, because we still got to put its arguments list in. So it's the name, parentheses, argument list. Well, the argument list is we don't put the actual name of the variable, we just put the data type. So, because health is an int, we're just going to pass in an int. Close this off. And what should a return type be? Do we need to return anything? No, so it could be a void. All we're doing is setting the value. And this is a very brief introduction to UML diagrams. Make sure I don't have anything else that I would like to introduce with it. So yeah, I think that's it. That's the very basics of a UML diagram. When I ask you to implement a class, you're going to see diagrams like this. You must follow them. Naming, security level, and stuff like that. Stray away from it, you're wrong, essentially. They're given to you for a reason. Any questions? Alright.
What's the sign to denote protected?
I don't actually have that written down right there. I think it's the hashtag though, yes.
What are we gonna use as diagram? Like
It's when you design your classes.
Okay.
When you get to your assessment, all of your you have to do documentation. You have to document your class and how they're structured. So you would submit a UML diagram saying this is how my class is structured. And by giving us a UML diagram, assuming all your stuff is there,
we should be able to implement that UML diagram on our end. That's what they're for. Essentially, that's what I'm gonna be giving y'all. Any assignment I give you that says create a class, I will give you a UML diagram. And I expect y'all to do the same. Like, if you ever want to go make a project on your own, I recommend you actually going on paper first, design your class out, and then start working. One, that way you don't get sidetracked and trying to figure out what you need. You have it all written down. Now, you can deviate from it to an extent, but just make sure you keep that core idea in mind. And that's what they're there for. So, I'm going to go. We'll take a quick little 5-minute break. So I'm going to the bathroom, and then we'll get right back to it, and then we're gonna go into the next set. So if you want to finish your snack, you can.
Actually, those snack packets, that's my snack here, basically.
We don't have an AIA window connected to anymore.
So would it be a light public awareness?
You connect to that one. Yeah, the password is lights at light. Or it's LPW. It's one of those. It's this. This is the. That's not. That is not the AIE network. So you can't connect to. It's light. LIGTHS at light.
I'm just wondering if it's AIE staff Wi-Fi or light public awareness.
You can't connect to the staff Wi-Fi. You gotta connect to the light one.
Oh, light public wireless.
Yes. And then that's the password. Goldfish pack. Let's run this back in. Start.
It says incorrect password.
One second.
Which Wi-Fi are you trying to connect to? LPW or like public wireless?
Might change the password. They might change the password to it. I don't know what it is now.
Yeah, I'm not surprised.
Alright. So I'm gonna get back in the groove of things. So I was gonna go over something else before this, but we're gonna follow this slide instead of jumping to another one before we do that. So up to this point, we've only written code in the source file. We don't always do that though. Actually, we'd probably say we never do that. We break our code up into multiple files. It could be multiple source files, or whenever you create a new source file, you see this other thing called a header file. Everyone's seeing that, correct? When they create a new source?
I think so, yeah.
Header files is where we usually put our class declarations at, and like just the body of it. And we use these source files for definitions. Does it mean you have to? No. Is it good practice to? Yes. Mainly because of when we get to libraries and stuff like that, we build our stuff out into, so we build the headers out and stuff like that, so you can still access them and see the definitions and stuff like that without actually seeing all these source code and all like the bodies of the functions. Maybe just so much. The header file, as I said, usually holds the definitions of the class, but not the definitions of functions inside of it. This is why I was saying something earlier about scoping.
because now we're gonna need to scope the things. If you notice one thing on the top of this file, this simple. Let me actually start it up so you'll actually read it all. If you notice that the thing on top of pre-processor directives, this if indef sprite underscore h defines sprite underscore h indef. We've never actually used that too much. Usually when you make a new header file, it has a pragma once, and it does it. It takes care of this. From what I understood, it actually does it for you. That stuff. I think there's actually something else. I could be wrong, so don't quote me on that. We don't normally, or I've never really done that pre-processor directive on top like that. So, in the header files, we normally just put the function prototypes and not the definitions, as I just said. And which is why I was stressing it on the board a little while ago. The CPP file, however, which what we've been going over, is the function definitions are placed inside the corresponding CPP file of the files. Usually when we name our header and source files for classes, they're usually named the name of the class. So if I was to make a header file for this class, what would I name it? Player.h. .h is the file type. Then when I wanted to make the source file for all our definitions, what would I call it?
Player.s.
No, player.cpp. CPP is the source file. You've already been using source files to this point. That main.cpp or source.cpp you've been making, that's a CPP file. The CPP file is beyond the class scope. So the class name and these double colons are a scope resolution operator must be used before the name of each function, but after the return type. So if you look at this example on the board, you see that include key that includes word again, that hashtag include. But it looks a little bit different this time. We're not using the chevrons. We're using, or the alligator mouse, whatever you want to call them. We're using some quotes. We use quotes when we're using user-defined files and stuff like that. We use the quotes for something that's usually included out of external dependencies. If I'm wording that correctly, I think I might have got it mixed up a couple words. But that's usually what we do. We need to include a reference to that sprite.h file in order for us to have access to everything inside of it. The scope resolution operators allow us to get access to the functions or variables inside of that class to give them a definition. So what we're going to do is, for more practice, because that's the best way I can explain this, is actually do an example. What I need everyone to do is open up Visual Studios, and we need to go ahead and you keep working on the same solution, or just make a new project if you want. That's up to you, because that's what I'm going to do. And then what I need you to do is, once you have that project created, I need you to add a new file, which I'll go ahead and pull my Visual Studio up over here. Add a new header file. So when you click new item, select header, and name it player.h, and capital P on player.
Name of what?
Player.h. No, the solution needs to stay the same. What you should be doing, you should make a new file called player.h, not player. Once you have the file created, you should see at the top you have that pragma once thing I was telling you about just a second ago. And now we're gonna go ahead and have a little bit of fun, kind of like we did yesterday with the structs. Let's go ahead and design us a class. We're making a player class. What are variables that define a player? We're not gonna worry about security levels right now. We'll do that in a little bit. So what are some properties of a player?
Health.
Huh?
Health.
So health. What kind of data type is that?
Int.
What's some other things?
Name.
Name.
Wouldn't like type of character, like class, if he was a tank or.
That requires someone to do more. Make another class.
No.
We're not there yet. No. We're thinking like basic character.
Oh, basic.
Resource. And what type is that?
Int.
How about M spiky hair? Let's make him a
Level.
generic shonen anime protagonist.
No, that's not a player trait.
Level.
Level.
Gender.
Gender's a good one, yeah. Because you can do male or female, so you Boolean.
Move speed.
Armor.
Huh?
Type, like you know how some games have different types of players, like
Right, that requires to define more classes.
Oh.
We're thinking pretty basic, yes.
How do classes work regarding customizable player avatars? Like, does that mean the data is actively modified as your?
That's inheritance and stuff like that. Because you would define. We actually students made a game last year where they had customizable ship parts, and different parts were different classes and objects and things like that that you can attach. So I think it's a pretty good player right here. So what are some functions or behaviors a player can have?
run. You mean like moving around?
Based on these abilities or these properties, what can
Lose
I
health.
Huh?
Lose health.
Lose health. So take damage. Do you think you need to take an argument for maybe how much damage he takes? Or does he take the same amount of damage every time?
Most of the times there's different amounts of damage you can take.
So we're gonna give him an argument for int. And what kind of return type should it be? Does it need to return anything?
No.
So we make this a void. Now if we had something like maybe hit and miss ratio, maybe return a boolean saying, hey, you hit, things like that. It would pretty depend on what our application is. For the time being, we're just gonna be very basic with it. What's something else we can do here?
Level up.
Level up. Does this need to take it an argument?
You might be able to level down.
That's actually a good. So maybe it says they level up, maybe modify level. And then maybe say maybe take in a boolean for, or do you think would be a good way to say either decrement or increment? Or do you think we just pass in the number of levels we want to increase or decrease? There's a couple ways we can do it. It's up to y'all.
If we do the boolean, we gotta do the condition of like why it's happening.
Essentially, yeah. So the boolean comes back true, we increment a level. Comes back false, we decrement a level. That'd be one way. Or we can just pass in the number of levels we want to change. If we pass in a negative number, we go down. We want to level up, we go +1. Or we pass in a positive number.
That would be easier to do just add instead of adding subtracting levels instead of doing the boolean.
Okay, we can do that. So we'll pass in an int. And we'll let this be as a void also. We'll kind of let everything be a void for right now unless otherwise. I think that's a decent place for now for us to start with our class. So one thing I would like to add though, or what we'll do is we'll leave everything public for now, actually. Just so we can understand how to access class data. So plus. So now that we have this UML diagram designed, we need to implement it following the very exact naming convention and data provided on the board. I need everyone to do that. We already know the syntax for a class. A class denoted by the keyword class, and it needs to be named, we said, by the UML player. Classes, just like structs, after the last squiggly brace, you need to put the the semicolon. And make sure you use your public keyword at top so that we can note everything below is public. So yes, if you notice about the UML diagram, I don't put the names of the arguments. The argument names are pretty, it's just to let you choose what the argument name is. You want to make sure it is you're able to identify what it is when you start using your code. If you give it some weird argument name that you don't understand what is supposed to be passed in, you're not going to benefit from it essentially, or it's going to be harder to use your code. Now, once we have this class defined, and since we have all the variables and functions that make up the data of the class, if you notice under the functions, yes?
You do it like it is on the board, put the type of variable it is after the name?
No, that's a UML diagram. That's not code. I lost my train of thought. Yeah. If you notice, your functions that you have in this class have a green underline on them. If you hover over it, what does that green underline say when you hover over it?
Overload.
Huh? Huh?
Not found.
Not found. The definition is looking for it. So we need to give it a definition, which we're going to do in just a second as soon as everyone has a class defined. the light bulb. With the light, I'll tell you what the light bulb does in just a second.
And what have this defined?
Yeah.
Relinsky?
That's not exactly how they are on the board, dude. And those are functions, not just those are functions, not variables. That are the return type of void. They take in int as arguments. You got a Relinsky?
Yeah.
Alright.
We'll kind of pass around real quick.
Save word. It's not prohibited. Again, you need to follow the exact naming convention I have on the board. Variables, or not variables, functions. The Pascal case, the first word's capitalized, the second word's capitalized, third word, so on and so forth, is all capitalized. You got it?
Yeah, Steven, yes, you got it.
So, once we have this, we need to get rid of those green lines. How do we do that? We need to give them a definition. We could define them inside of the class, but we don't want to. That's not what the AIE standard says. We need to define them in a source file. So, what we're going to do is go ahead, right click on our project, add another new file, make sure it's a source file, and name it player.cpp.
So another one that says player.
Player.cpp, yes. Everyone has this? So it should look it's just an empty file. It needs to be empty file, nothing on it. So in the slides you saw it use that include keyword and included the name of the file where the class is located. Why do we do that? We do that so we can get access to the information in that file. So we're going to need to do that right now, where we need to include the player.h. So hashtag include double quotes player.h and use your autocomplete. Not a lot of you are using it. Autocomplete is not a bad thing.
Double quotes, just one set of quotes. So, doing this, as I stated, gives us access to the information in that file, which means we have access to that to create an instance of that class. But we don't need to do that right now. We need to worry about defining those functions that we had. How do we do that though? So, I mentioned a thing in the slides earlier about the scope resolution operator. There's double quotes or double semicolons. The double quotes lets us know that we're defining a function that's inside of a class, or something that's inside some kind of data type, data that's in a class. We're giving a definition. This double quotes, it goes to define a function outside of the scope of the class file, or the scope of the class. It's return type of the function, name of the class, or space, name of the class, scope resolution operator, name of the function, argument list, body. So, don't start typing just yet. Based on what I have on the board, how would I access the take damage function? What would I need to do? I'm in another file. What do I need to type? Void.
Take damage.
This function and this function are not the same thing. That's an entirely different take damage function. So this is
No,
not
you
correct.
void player.
Huh?
You player. Then the double.
My question is, are
double
we writing
colon.
void at all?
Huh?
Are we writing void at all? Like, are
Yeah.
we writing a function to access the function?
We're writing the definition of the function, but we need to make sure we're actually defining that function. That's what the scope resolution does.
Then it's take damage.
Let's take damage. And then our arguments. There's the body. So it says we're gonna give the definition for a player take damage function. It's declared right here. And this is the body for it. Make sense? Everyone do it in visual right now. Inside of that player.cpp file. I'm gonna erase what's on the board. Gonna pass around. You can, I don't care what you name it, but you want to make sure it's something meaningful to you. So maybe amount or something like that. So look here, Joshua. See. See if you get here or something like that. So when you're doing the prototype, you don't actually have to give it a name here. The reason you do it is just for clear, to make it clear what you need to do. That way we don't have to go to the source file every time. So you need the body. Good job. Couple little syntax issues, but yeah, we're getting it. Need your body.
That's the scope, huh?
Yes. So there we go. I'm gonna go ahead and type it up on my end. there we go. A lot of you may have noticed when you did those scope resolutions, you saw everything that was in the class and accessible from that scope, correct? That's your friend. The autocomplete is your friend. Use it. You saw how fast I didn't have to type out take damage the whole way. I was just void player. What do I want to do? Okay, purple are functions, blues are variables. Let's do the modified level. Okay, what kind of order gonna take? Take an int, and we'll do value. That fast. Use it to navigate through it. Use your I call it the directional pad or the arrows. Use that to navigate. Hit enter. It auto completes it for you. To bring up the autocomplete, control space. Control space is a lifesaver. Because numerous times I'll be coding and it's like, dude, I don't know what I need to write. I don't know what I need to do. Let me browse all the functions in this class. There's an add to vector thing. Okay, yeah, let me do that. And help me out. So just don't be afraid of it. I know it could be overwhelming with the amount of functions and just all the tools visual gives you right off the bat. No, that doesn't say you should be scared of some of them because some of them do look a little scary, but the ones we see commonly are not that bad. So let's go ahead and actually define our function for take damage. We know, what does it mean to take damage? Someone tell me.
You lose health.
Lose health. What does it mean to lose health?
You're dying.
Dying, or the value of health is decrementing. What's that? Decreasing the health value. So let's do it in our take damage. This is where we're going to introduce this new keyword called this. This keyword says that this class or this instance, then we use this arrow operator. Let me pull up the name of it.
Is that what you were talking about yesterday?
Yes. The actual name of that operator is called the I know, I wrote it down. Oh, 1 second, I know where it is in the book. I actually jumped ahead in the lesson. That is actually, I don't think we need that. So yeah, we don't actually need this keyword. Don't worry about it. Forget I said it. That's another lesson. That's actually for pointers. You can still access it without it. When we get to that lesson though, I will expect y'all to use this keyword. One, because it's clear as to where that variable is coming from, because I've had issues with it. So, because with that scope resolution operator, we are saying we're in the scope of the class. We have access to all the variables and functions inside of it. So how do we do? We can just literally type the name in. So say I wanted to invoke the modify health function. Do that. Bam, executing and passing a value. Don't type this in. This is an example. The modify level function, I could call it in because I have access to it. Because we're in that scope. That's what the scope resolution operator does. If I just did this, I would not have access to that modified level function because we're not in the scope of the class. That's what the scope resolution operator allows us to do. So back to what we were talking about. We said the take damage function needs to decrement our health, correct? By what?
However,
10.
however much is inputted.
Not input, whatever's passed in. So yes, essentially we'll do, so we'll access the m health variable, and we'll just do minus equals amount. So what that'll do is that'll say, hey, your health, let's subtract it from the, set its value equal to itself minus the amount passed into the function. So, let's test it. Let's make an actual player object and make it take damage. So, go ahead and make another new file. And you can name this one just source.cpp. You will need to include a reference to the player.h. That way we can have access to the player. Make your main, and then just put system wait, do we not have access to system calls? Okay, make sure you include IO stream. Once we have the main in there,
You said under the source files or the resource?
you're making a new source file. It's called main. Just call it source.cpp or something like that. You need a new main. You need to make a new project, man. You're gonna have all kind of issues with that. You can make multiple projects under one solution. If you look at my Visual Studio right here, every single one of those purple boxes on this bar is another project under the same solution. This way I can have multiple entry points defined and I can constantly swap out. And because it's easy to version that way, I can send, like, it's all versioned on the one repository to for everyone to go look at as they need. Sorry?
I'm supposed to use the alligators.
For player.h, you don't use the alligators yet.
That's easy.
Wait, what was it that you chose?
Why don't you just leave it like this right now? Wait for everyone to get caught up. Yesterday I said I was running a little too fast, so we're gonna slow it down a little bit more with the examples. Okay, so say the one person. Everyone has it? You got a Roland's key?
I'm trying to get to the one I had saved so I can just copy everything from it.
No copy paste.
Yeah, that's what I'm trying to do.
No.
Just retype it.
Retype it. Never recopy and never copy and paste. Unless I tell you to. Don't talk copy and paste is code that's already in my project.
Just noticed this comment in the general channel for Slack. It's from Krista. If you clock in early or clock out late to make up hours, please notate it in the notebook so I know. Also, many of you are forgetting to clock out. If you get to clock out, please write it in the notebook or the next day. Notebooks the next day. Thanks for your help. So yeah, make sure we're just if you clock out, if you forget to clock out when you walk in the next day, say, hey, I left at 6. Or if you stayed an hour late, which I don't think any of y'all stayed an hour late to do anything, just say it. Also on Wednesdays, if you do stay to make up hours, you need to clock out and clock right back in, and then clock out when you leave. All right, you got it, Renetsky? Oh, dude, you got so many visuals open. Close all the ones you don't need right now. I can't help this right now. Like, there's so much going on. Can you fix something for me, TJ? It's okay. I'm just gonna talk right now. As I was stating, we include the reference to the player.h so we can have access to the class. And there's a couple reasons why we want to do that. One, to define the functions as we just did. And two, so that we can actually make instances of that player class and make player objects. How do we do that though? Same way as when we did structs, pretty much. So you could still actually get on the board where I just created the instances. We could do the same thing, but we have we have to assign the data as we go along, essentially accessing the variables until we get to another concept called constructors and deconstructors. And we can also write functions to do it for us if we wanted. For right now, we don't care about that right now. We're just gonna assign it manually.
Oh, that reminds me. Since there's a keyword called struct, is there a keyword called destruct?
Type it in and see. I don't think so. It'd be blue if there was.
Red line.
Yep, so it's undefined. No, so there's not one. I didn't think there was. So yeah. We're just waiting for him to get caught up.
words derived from just one single class?
I'm sorry.
If you're fighting hordes of the same type of enemy, are all those enemies derived from one single class?
Probably. Yeah, they're all the same type. They're all the same type of object, just different instances of it. So, say you have 50 enemies, they're all an enemy, but they're different enemies, so they have their own properties and stuff defined with them. So you just make multiple ones, kept instantiating them. Answer your question?
Yeah.
Yes, that's what classes give us the power to, essentially, so we don't have to keep defining all those variables. We can have multiple of the same type of object with different things assigned to them. Like I can have 2 students. I can have one that defines Luke and one that defines Zach. They're both a student, but they're 2 different instances.
This is
Make sense?
alright.
He's caught up, TJ?
Yeah.
Okay. So, now that we have this, we need to create the instance of the class. How do we do that? Same way we made a struct. It's the class name, so in this case it's a player. Then the variable name. So I'll make me a player with my name. I want y'all to do one with your name. So TJ's would be player TJ, player Olinsky, player Brett, player Luke, player Matthew, player Zach, player Steven. Still following the naming convention, lowercase letters. Once we have an instance defined, we can now access the public data inside of that class. Keep that in mind. So let's go ahead and assign a health value to our variable. To access it, we use this dot operator just like a struct. This is where the similarities come in. Nothing's really changed here, so I just go variable name dot, and I look at a value with the what I want to get. I want to assign a value to mHealth, and I want to assign it the value of 100. Everyone needs to do that. Once you have that, I need you to assign the rest of the variables some kind of value. For the gender, male is true, female is false. I'm just going to pull my screen over so y'all can't see.
You said male is true?
Yes. Don't worry about saying the name right now. I don't know why it's giving me issues. It might not be X modifiable outside of the class. Which doesn't make sense why it is. But we were able to do it yesterday. Alright. So you should have a value assigned for health, gender, level, and resource. I don't care what those values are.
So when we put a
No, it should be lowercase t, lowercase j. 20 words. No, oh, so he hasn't defined the class yet? already said he was caught up.
What do you want me to do? Oh,
I just need him to. I need him to get. I need him to get to where we need to be. Where we're at.
oh, okay.
Just,
So you want me to
just type it in for him real quick, just so we can get it going, and we'll get him caught up later on. Yeah, you ain't gonna roll. You ain't gonna get it out. Red line. So yes, this just seemed very familiar to yesterday's lesson on structs and how we access the member variables. I'm just gonna go ahead and throw this back on into here. And you can see my responses here. I have 100 health, male, level 7 and Night Elf Mohawk, and I have 50 resource. So yes, does everyone know that reference though?
Isn't that like
No.
a WoW?
Yeah, it's the old Mr. T WoW commercial. So yeah, let's wait for everyone to see. So far, how's this making sense to everyone?
It makes pretty good sense because of like yesterday, so it's pretty similar.
Mm-hmm. Again, the big difference is the fact we declare the functions inside of it, and the security, the protection levels. That's the big takeaway from it. And then we're learning to use source files. We're learning how to structure our code better, which is kind of why, like I was saying, we need to work on naming conventions and things like that. I was stressing them pretty hard early on, and how we do that. And I think that's what was a lot of the confusion at the beginning was you're learning name conventions, syntax, and how to code. And think now it's up there. We're up there in the difficulty section. We're just gonna kind of coast down almost now. Because again, once you know this, we can start doing stuff now. You good now, TJ?
Trying to get the
So, so much stuff right here. Get rid of this, we get rid of the hair. Yes. Yes. So we're working on this file, this project right here.
yeah.
Nice. Set a start project. We'll put player.h. Close this, close this. So this is good. No, this is not. You don't have a player name. From there we can go to player.cpp. Now we have access to everything in player. Open up our source. We have access to the main. We need to system pause. Now we're good. All caught up now. So I need you to do this now, Walensky. Try not to copy off the board. Like I gave y'all the health one, just as a reiterate what we did yesterday. Left truancy?
No.
What's wrong? Semicolon here. Right there. That dot operator needs to stay. Since it's also not proper naming convention. Parentheses shall be lowercase. Remember, variables, all lowercase for the first word, second word, first letter capitalized. So you need a semicolon at the end. Now you can keep on going. So you didn't make everything public either. So you gotta use a public keyword. So now you have access to everything. So